welcome to Climate Action Santa Monica's Water Forum for November of 2014. I want to give them a round of applause. Now, some of you are probably asking the question that I was asking on the way over here. By the way, my name is William Selby. I teach at Santa Monica College, and some of the great classes I've had the privilege to teach are weather and climate, our environmental studies class. I also host our environmental and urban issues lecture series at the college that we have on Tuesday nights every semester. We have some great speakers in that, but none of them as good as what you're going to hear today, of course. So I'm coming over here on my bike today, and I've had the honor of introducing some of the speakers and looking after things today, and I was thinking, why am I doing this on a Sunday? Because I was thinking, you know, what really is important to me, because I saw it on the news, it's in the popular media. What's really important to me is how my favorite celebrity is wearing their hair. Because I've seen it over and over again, and then I thought, it's Black Friday. I got to think about Black Friday. How am I going to get out there? How am I going to fight to get what I want, to purchase what I need? And it began I began to realize that this is what I'm seeing with the popular media, that these are supposed to be the things that are really important to us, right? And then suddenly, on my bike ride over here, I realized that I was breathing air. And that without that air, I wouldn't be able to come over here. I wouldn't be able to go to the mall. I wouldn't be able to worry about my celebrity's favorite hairdo, right? And then I realized, oh, the second most important thing in my life, and yours too, is water. Because without water, there's no way we can do all the things that we do in our lives. We can't have friends or family, or we can't experience love or the beauty of the world. And so that would be the second most important thing in my life. And the third most important thing in my life, and now I'm already getting really excited because I'm on my bike, and so one of you is probably cutting me off, and I'm thinking the third most important thing in my life is food. Right? If I don't have nutritious food, I can't do any of those things that they're telling us in the popular media that we need to do to stay, happy. And so then it suddenly I realized that no, it's not that stuff that's really important. It's this stuff that we're doing today. It's about air, it's about water, it's about food, and how climate change is changing the way we think about those things. The availability of those resources, and our health in general is being directly impacted by our availability of water, how we use it, whether we have access to fresh water. And to remember, 1 billion people plus on this planet, that's with a B, do not have access to fresh drinking water. And so then suddenly the popular media wasn't in my mind anymore. And the things that were really important to me became important, to me. I guess I already said that, didn't I? And then I was thinking, but so wait a minute, I'm not really the host here, right? I'm not really the host. It's these climate change people, right? The Climate Action Santa Monica people. Could you please stand up, because these are the people that organized this. Just stand up. Climate Action Santa Monica people, come on, you folks in the back. They're very shy. There's more of them here, but they're very shy. So we want to thank you, first of all, for making this happen and making the mistake of inviting me to introduce the speakers. And the good thing is that, when I get to invite the speakers, then the speakers look even more important than they actually were, which helps a lot too. All right. So this is what Climate Action Santa Monica is all about. We all know that the climate's changing. We all know that it's affecting our lives in profound ways, even though we're not reminded about it in the popular media. And then it makes me think of one other thing, Janet, and that is, if air, water, food, and the basic resources that we have available to us are the most important things in our lives, then what would be the second most important thing? And I would argue that it is considering where we came from, what is our purpose here, and where are we going? And that's where I want to introduce Janet. And Janet is the minister of the Church in Ocean Park, and they have been, the Church in Ocean Park has been instrumental in incubating in helping to organize this climate action group. And I thought Janet might want to say a few words about her church. All right.
Good afternoon. Good afternoon. The church in Ocean Park, just bring you greetings from the church in Ocean Park. The first 2 forums were held at the church in Ocean Park as sort of the incubator of Climate Action Santa Monica. And we are a diverse interfaith community dedicated to social justice. I bet some of you in here have actually been there before and organized some stuff out of there. Yeah, so they've been organizing, we've been bringing people together there to organize for positive change in this community and beyond for quite a while. And we're continuing to do that, not only with this Climate Action Santa Monica, but also we have a Committee for Racial Justice, which is working on education and mass incarceration and outreach into the community. And we also work with LGBTQ folks. We had our first annual queer prom at our church last June, and we'll continue to do that. We have a lot of different focuses that we're working on, but nothing would matter, as Bill would say, if you can't breathe. Right? So if we don't have a healthy planet, none of the other stuff that we're doing actually would matter. I do want to tell you that this is the kickoff for our open house. We have a month-long open house, and if you go to our Facebook page, you'll find out all the things that are happening. But we also are interfaith, so in December, we are celebrating all of the different holidays and holy days. So if you come on a particular holy day, we might be celebrating Bodhi Day, or Hanukkah, or Kwanzaa, whatever it is. So not only are we interested in what happens in the world, but we are interested in why we do what we do. So you're welcome to come and join us and look at our Facebook page.
Yeah, the great thing about having so many distinguished speakers is that I get to take a breath, and I was standing there thinking, wow, I'm really excited about this event. So I got to get a deep breath and calm down a little bit. And I think it's my job now, and the group over here, they're going to yell at me and remind me when I don't do something right, which will be most of the time today. Anyway, I think it's my job now to do a little weather update. Is that right? Would you like to see that? Okay, let's bring the lights down a little bit. See if that works. Well, that didn't work very well, so let's try...
You need to stay near the mic.
Oh, yes, thank you. Thank you for that. See, there's something already, and let's see here. There you go. Okay, and I have my pointer, so at least I did. It may be that somebody else got the pointer very quickly, so anyone out there got the laser pointer? There it is. This is Zach, by the way. He's really making this happen. Zach, thank you. All right, everyone. Well, I got the latest satellite image, and I wanted to talk a little bit about what our last 3 years of drought have been about, or what we think they've been about, and what we think might happen in the future. And this is the best way to show it. One of the things you may have heard of, so I have 1 minute and 17 seconds. Okay, one of the things you may have heard of is that we've had this omega high over Southern California and almost all of California on and off throughout the last 3 years or so. And what that's about, it's a blocking high, and a high pressure system is it's really easy to understand. It's heavy dense air that sinks and it creates stable weather over us. And when we have stable weather, we don't get storms, we don't get rain, right? And so that blocking omega high has been stuck over us on and off throughout the last, well, 3 years. Now we all know it's there during the summer, but it's supposed to move away at least sporadically during the winter, and it hasn't been doing that very much lately. And that includes the beginning of this rainy season as well. Most of you probably know that a rainy season runs roughly from November to April or so, and if we don't get rain during those months, we're not going to get any decent rain, right? And there it is, folks. It's back, and if I could push the right button there we go. Now, this doesn't have all of the characteristics. Today's weather, is a little bit different, as all days are, of the typical omega-shaped high, and that's the good news, because this high pressure system that we have over us today, it does represent sinking, stable air, a lack of precipitation. You all see how clear it is out there. We're even getting a strong offshore breeze, and that's our first major or powerful Santa Ana wind of the whole year. So all of that's bad news if you don't like drought, obviously, because it's very dry outside and the fire danger is still quite high, and it's going to be until we get some decent rains. So here's what has to happen, so you can watch for it now. By the way, you want to watch for it on the National Weather Service sites, and I can give those to you if anyone wants them. Just go to the National Weather Service in Los Angeles. You can Google it and you can get all this information yourself and bypass the middle people so you don't get the song and dance with it, right? Anyway, so what's happening to our high pressure system? It's pretty strong right now. We've got the offshore winds. We're on the opposite side of the mountains from the wind. We call it the leeward side, and that means it's going to be dry and warm for the next couple of days, except at night, because the air is very dry. It cools off pretty well at night. You might have noticed that last night. Things are changing, though. This high is going to budge away, and this low pressure system over here is going to start moving toward us. And as it does, it's pretty likely that we'll get in Northern California some rain during the middle and latter part of the week. And many of you who have been up there may know that they've already been getting rain this year. They started with a relatively decent rainy season way up toward the Oregon border. And we're hoping that what's going to happen this year is this high will finally break down, slide south, open the door for these storms from the North Pacific like it usually does, and we'll start getting some rainfall. But here's the problem, everybody, the uncertainty. And this is what you don't hear in the media. We know it's been dry. We're concerned that it will remain dry and that Omega High will come back. But we don't know that for sure. The meteorologists will tell you when they're watching these weather patterns change, and it looks like we're in for at least a pretty good change for the latter part of this coming week, what we want to do is hook up to the tropics. And we used to call that the pineapple connection. Some of you might be aware of this, and I'm going to show you how it works. These storms are generated in the North Pacific, and the wind blows around a low pressure system or a storm in a counterclockwise direction. Is it too much information already? Okay, so what that means for us is that if those storms can make a connection, if these upper level winds can make a connection, and lower level too, to the tropics, they can drag that tropical moisture up toward us, right? We used to call it the pineapple connection, and steer it into these storms where the cold air is, and we'll get copious amounts of rain. This has happened before. For instance, during El Nino years. In 1983 it happened. In 1997-98 it happened, where we had powerful El Ninos. That means warm water in the eastern Pacific, a lot of tropical air or subtropical air being thrown up into California just before these storms hit. We got over 30 inches of rain in both of those years. All right? Now, you might know that we started this year hoping for an El Nino. It looked like everything was coming together, but the latest information on this is mixed. The water temperatures in the eastern Pacific remain above normal for the most part, but the trade winds and the other signs of sea level rise and lowering are not there anymore that would indicate that we have a powerful El Nino this year, and that's what you've been hearing about in the media. The early warning signs of a big El Nino have subsided, but it looks like we might have a mild to moderate El Nino. No one knows for sure. We're getting well into the season now, so we might be getting a little bit too late to call this a powerful El Nino year. But you can see why it's so important. If we can get warmer water temperatures off the coast here, we can get those storms to drive that moisture up into California. And this wasn't a little bit oversimplified, but it gives you an idea of what's going on out there. There's also this thing called PDO, the Pacific Decadal Oscillation, that I'm not going to get into in real detail, but it appears that we could be on the end of that cool period and stable period, and hopefully one of these good El Ninos will kick us into a warmer period and a wetter period. But nobody knows for sure, and that's what I wanted to make sure we understand here. We don't know exactly what 2 or 3 or 4 or 5 weeks ahead is going to bring us as far as rainfall goes or drought. And that uncertainty is the important thing here. If we get what we now call them atmospheric rivers, if we can get a low pressure system forming off the coast, or even a couple of them, they connect with the tropics, boy, we could have a beautiful rain year. But nobody knows for sure what's going to happen. And that uncertainty means that we have to plan for the future. If we continue with the drought that we've had over the last 3 years, we'll be in the most critical water environment that this state has ever faced, and we're probably there already now. But you think it's bad now, you wait for 1 more year of drought, and literally, we don't know what we're going to do after that for a lot of these communities who are running out of water. So getting back to what I wanted to emphasize, it's a world of uncertainty. We know that the climate is changing. We know some of the reasons for that climate change, but it's very, very difficult to predict exactly what's going to happen next, because this is an experiment that we've never run before. And from a scientific viewpoint, it's really exciting. But from a practical and humanitarian viewpoint, it's really dangerous. And so what that does is it gives me an opportunity to connect with our first speaker. Where's Rob? Where'd he go? Rob, there he is. Good. I wanted to make sure our speakers are here before I introduce them, right?
That's managing risk.
Yeah, so here goes. Here goes. Wow, we have the most incredible speakers. Rob Limpert is a senior scientist at the RAND Corporation and director of the Frederick S. Pardee Center for Longer Range Global Policy and the Future Human Condition. His research focuses on decision-making under conditions of deep uncertainty. I have this all memorized. I just want to make sure I've got it down, okay? With an emphasis on climate change, energy, and the environment, Limpert and his research team assist a number of natural resource agencies in their efforts to include climate change in their long-range plans. He has also led studies on national security strategies and science and technology investment strategies for clients such as the White House Office of Science and Technology Policy. Limpert is a fellow of the American Physical Society, a member of the Council on Foreign Relations, a member of the U.S. National Academy of Sciences panel on assessing the impact of climate change on political and social stresses. I think I'm a little stressed out just thinking about it. And a lead author for Working Group 2 of the United Nations Intergovernmental Panel on Climate Change, the 5th Assessment Report, and for the IPCC Special Report on Managing the Risks of Extreme Events and Disasters to Advance Climate Change Adaptation. It is for this work that Mr. Limpert was awarded the Nobel Prize. Additionally, Limpert was the inaugural EADS Distinguished Visitor in Energy and Environment at the American Academy in Berlin. A professor of policy analysis in the Pardee Rand Graduate School, Limpert is an author of the book Shaping the Next 100 Years, New Methods for Quantitative Longer-Term Policy Analysis. Limpert received his PhD in Applied Physics and SM in Applied Physics and Science Policy from Harvard University. Please welcome Rob Limpert.
And after all that, I'm going to have to rely on Zach to get my slides up. Great. Okay, good. Oh, and this is not going to work on my machine, right?
Oh, but it will.
Oh, it will. My God, that's really impressive. Okay, great. Okay, so, oh, there we go. Okay, great, good. Okay, great. Well, thanks a lot. It's a real pleasure to be here. So I think my job is to lay out some of the broader context. And I gave my talk this somewhat nerdy subtitle with this word stationarity to really pick up on the theme that Bill emphasized, which is uncertainty. And I'm not going to give you my basic climate science and why the climate is changing talk, but often when I do that, I start out with a graph which shows the variability of climate going back 100,000 years, and it's got a little X on when humans started to become cognitively modern, which we can tell because they left cave paintings which look like people today would do, and then when you first get cities. And what it shows is people were, human beings were cognitively modern about at least 40,000 years ago, but we didn't start settling into communities, agricultures, villages and such until about 10,000 years ago, and that's about when the climate came out of the last ice age and stabilized. And so it's really fair to say that, and now what we're doing is we're driving the climate into a period where it's going to be more unpredictable and more unstable than it has been for the entire time that humans have lived in organized, civilized communities. So that is sort of the grand statement of coping with uncertainty, and I'm going to start out with some discussion of water, but then take back to how do how should we think about managing and planning under those conditions? So Bill also mentioned the IPCC and the Nobel Prize thing, and so, which is also on the flyer for this thing, which made it hard to send out to my friends. And so this is, so I would just want to say a few things about the IPCC. So this is a very large group. There are thousands of scientists in the IPCC. Anyway, so I'm just showing over the last 6 months, the fifth assessment report of the IPCC has come. Great, no, thank you. And so the first one has to do with climate science. The next one has to do with impacts and adapting to the effects of climate change. And the third one has to do with mitigation. I'm involved with the second one. This is the authors, the lead authors of that. So the arrow points at me up there. So just to give you a sense of how many people I share these accolades with. Really interesting reading. There's actually a 2-page summary out for those who don't want to read through all 4,000 or 5,000 pages. But the really salient messages for today is, climate change will have significant impacts on water resources. I'm going to just, scan through some of those ideas. And the other important point is, we look across many sectors, but in particular for water, we're really going to have to manage those resources very differently in the 21st century than we did in the 20th. Okay, so first off, let me just emphasize that water is a multifaceted challenge. We think a lot about supply, but we also need to think about flood, we need to think about quality, and part of managing water appropriately in the 21st century is thinking carefully about managing all these things simultaneously. Very much in the 20th, we manage them separately, which is not something that is going to work very effectively as we go forward. California water's a particular challenge in California, in large part for 2 basic reasons. One is our water is in a different place than our people. So let me see if I can make this part yeah, there we go. So, this shows where it rains a lot, and this is where most of the people live, so the water is far from the people. And then we have this semi-arid Mediterranean climate, which is very variable, not only during the year. I mean, we get all our rain, to the extent we get rain, during a couple of months, and it's dry the rest of the year. But it's also, some years are much, much drier than others. And those recent charts that Bill was showing you are just give you some indication of the variability. But some years we get very little water, some years we get a lot more. So this is actually very difficult situation in which to manage water. So how have we done it in the past? Well, in the 20th century, we basically built large engineered systems and over-engineered them. So we built this vast system of dams and aqueducts, sort of the second one of the wonders of the world, to move water from where it is to where it was needed, store water for times when there was too little to get out the year-to-year variability, and then we kind of don't think about this anymore because we've done such a good job with it, but we've got all this infrastructure that when it does rain hard, that takes all the water and gets it out to the ocean as fast as possible to keep it from flooding us. And we manage variability, as I said, with excess capacity. So this is just a little chart which shows the population of the city of LA over the last 100 years and our major infrastructure projects. And when we built the LA Aqueduct, I mean, hardly anybody lived here, and we built it much, much bigger than we needed. It was built for a city much larger than the people there, in part so to encourage growth and grow into it. This is the Colorado River Aqueduct. Again, for the first number of decades that it ran, it had far more capacity than we needed. The State Water Project. And so basically, we way overbuilt the system to manage variability. And even without climate change, this system is now under significant stress. I'll talk a little bit about this, but we no longer have more than we need, and we've been using a lot more than we have. Okay. These charts aren't nearly as fancy as Bill's, but hopefully they'll be useful. Southern California owes its semi-arid climate to basic global weather patterns. And so, this is the basic, and this is just, sort of basic physics, and it's often useful to emphasize the basic physics because the models are very complicated, uncertain, and there's, a lot of controversy about climate change, and it's just important to emphasize that the basic patterns we see are to very simple, well-understood principles. And so it's warmer at the equator, right? And when you heat air, it rises, and hot air can hold more moisture than cold air. So we have wet air rising from the tropics, and as it rises, it cools off, and so it rains a lot in the tropics, and then the air circulates around and comes back down in the mid-latitudes where we live, and so we get this dry air coming down. And so that basically means it's wet along the tropics and dry in the mid-latitudes, and also the moisture that does come here, we do have here, tends to get blown back towards the equator and also up to the poles. So just basic weather patterns. Okay. And then if you run the models, and this is from the IPCC, the latest report showing current distribution of water resources. This is stream flow. So, along the equator, it's generally really wet, and in the mid-latitudes, it's a lot drier. And I know this, I think, really important point here is that if you look across these regions here, you can be, sort of rich, the wet areas, you can be rich or poor without being too fancy about your water management. But in these mid-latitude areas, the wealth of a country, the GDP, the people's quality of life, correlates really strongly with the sophistication and investment in the water management. So in other words, to live in a place like California and live, with a high quality of life, you really do need a very sophisticated water management system. Okay, so climate change has some pretty basic and well understood effects on this process, which is that it's going to make the air hotter, put more energy in the system, so we're going to get more evaporation in the tropics, and so more intense storms there, and more evaporation here, but that means we're going to have more of our moisture carried away. So in general, it's going to make the wet areas wetter and the dry areas drier. Okay, and if you look now across what the climate models tell you, and this is again from the latest IPCC report, and this is 5 climate models, global climate models, 11 hydrological models, and this is a 2°C world, which is one that we'd be, have to do pretty well on the mitigation front to hit. And basically where it's red, it gets drier. Where it's blue, it gets wetter. And the depth of the color is how much agreement there is among the models. And so in some places we're pretty sure what's going to happen. In other places we're a lot less sure. I've got a blow up of California here, and we're in one of these areas where it probably gets a lot drier, but it's pretty hard to tell. So we're not really sure what the total pattern is going to be. And this, accentuates this, or makes this point that Bill was making of the uncertainty, certainty of change, but the uncertainty of exactly what change we're going to see. And then there's also, that was water supply, this is flood, and again you see sort of similar patterns is, along the equator, there's areas where the flooding is going to go up a lot. There are areas where the flood risk goes down a small amount. What this is how much more frequently the 100-year pretty serious storm is. Oh good, that worked, okay, great. And this is the blow up of California, and California seems like our flood risk is going to go up rather substantially. Okay, just say a few words now about California water, but start that out by discussing the importance of groundwater, which is really central to both, California's water system and some of the challenges we're having. And basically, groundwater comes from our precipitation. It infiltrates down. We've got the groundwater down there, which in some cases has been there for millennium. And so groundwater is an important source of water here and a place where we can store water often. So now, just to say a few words about how California's water system is under significant stress. This is the Colorado Basin, where we get about a quarter of our water shipped by Metropolitan across the Colorado Aqueduct to us here. And this is the iconic picture from the Bureau of Reclamation, which hopefully shows up so you can see it. But this is basically water use and water supply on the Colorado Basin over the last century. And so we allocated the river among the 7 states of the Colorado Compact in the early 1920s, and which turns out to be the high water mark for the millennium. Okay? But that didn't matter so much because really only Californians lived in the West, and there was a lot of excess supply. So even absent climate change over the last 100 years, the supply has gone down a little bit, but the demand has gone up. And so basically demand has crossed supply. Okay, and this is true as you look across our infrastructure. And then we're been using more than we have. This is a map of groundwater stress in California. It's only like in the last few months that we've actually started monitoring and regulating our groundwater in a systematic way. But we have been, we have huge stress, particularly in the Central Valley, where we've been using groundwater to supplement our water in a way that's completely unsustainable. So no longer have more than we need, been using more than we have, and we add to that climate change, which is now stressing the system both by, more flooding, potentially a lot less supply, and certainly a lot more variability. Okay, so how do you think about these things? The IPCC joins many others in thinking that a really powerful framework for thinking about these is to think about this problem in terms of risk management. And so there's three key components to risk, which is hazard, which is the potential occurrence of a climate-related event that could cause injury or damage. And so here's a drought map of California. So a drought is a hazard. Exposure is the presence of people or the things we care about in places that could be adversely affected. And so, here's a big city like Los Angeles with many million people living in a semi-arid area. And then vulnerability is the predisposition of a person or group to be adversely affected. And so this is some irrigation in the Central Valley, crops in the Central Valley which require irrigation to survive. So these three things together, hazard, exposure, and vulnerability, create risk. And then to think about how to manage risk, you need to think about each one of these three things. Okay, so reducing risk in the 21st century really requires us to focus on what's called integrated water management, which means managing the water system as a more integrated whole and looking at both the hazard, vulnerability, and exposure all at the same time. So among the things we need to do, and I'm sure Deborah and Dean are going to talk more about these as we go through, but is we need to use a lot more local supplies, so efficiency, water recycling, rainwater capture. We need to make space for water, so rather than building concrete channels to get our water into the ocean as quickly as possible, we want to make multi-use situations which both control flood but allow the water to infiltrate into the ground so we can get it in our aquifers. And then finally, we want to operate as an integrated regional system which helps us share and manage risk. And this is a picture of the metropolitan system, we're of course here, which allows to us to find the most effective supplies across the region and manage risk across the system. Okay, and such strategies, when you combine these, are low regret. So as Bill was suggesting, no matter what happens, these sorts of things are a reasonable way to go, whether it gets wetter or drier. There's significant co-benefits, for instance, the sort of recreational benefits you get here, and it's resilient, it's robust over a very wide range of climate futures, which is our way of managing the uncertainty. I just want to say a little bit about the sort of work that we do, because I think it lays some useful concepts, which is essentially effective risk management requires stress testing water plans over many futures. And so I'm going to give an example here which hopefully sets up some of the conversations to come. But in some work that our group has done with Metropolitan, we've taken their 2010 Integrated Resource Management Plan, which is one of these integrated water management plans, and instead of testing it against one or two futures, we've run it over nearly 4,000 different futures, with each is a combination of a different climate future. So we look over a wide range of climate futures. We look over a wide range of future demands, and we look under a wide range of different scenarios for how effective different parts of the plan are. And then we ask the question, what are the characteristics of futures where the plan works well? What are the characteristics of futures where it may not meet its goals? And the latter are situations that we need to watch for and think about adjusting over time. And so what you get out of that, not too surprisingly, is that the key drivers are the demand and supply, which is largely what climate change does to us, and a smaller amount how effective we are at getting our yield out of our groundwater resources. And up here, this is the best case estimate used to develop the plan. The plan works great, but down here is this scenario, which is a combination of high demand and lower supply, where the plan would need to be adjusted. And one of the things you can do with this then is get warning signs that you may be headed here, and which allow you to, in a timely fashion, update and adjust the plan. And the range of climate projections are pretty much the full range here. So it does say that this is something that needs to be watched. So just to finish up then, the changing climate is, in some sense, sort of the final nail in the argument that we need to manage our water resources differently in the 21st century. More extreme storms, some places drier, others wetter. Ours is sort of right in between. But really this key idea that for 100 years we've built all this infrastructure, managed our water system under the assumption that what's coming can be usefully predicted by looking at the past, and the past is no longer prologue for the future. And so we really need to manage differently. And then this idea of integrated water resource management can help reduce risks, manage all these components in a coordinated way. This then, it's easy to say, but it actually then requires both our government agencies within jurisdictions and among jurisdictions to work together, closely together in the way that they have not done in the past and are sometimes not. Sometimes it's hard to do, and also requires us citizens to become more responsible and knowledgeable consumers of water, which is why it's great that you're spending your Sunday afternoon in a dark room instead of outside in the beautiful weather. And this idea of we really do need to stress test all of our plans against multiple futures to understand where they succeed, where they may fail, and then really expect our plans to be, works in progress, which adjust over time, and which in some sense is easy to say, but is actually often hard to implement and hard to come to grips with, of living with such an uncertain and contingent future. Great, and I think I'm done. We have a website with a lot of this stuff on there, and I think it's time for questions.
Okay, Rob, thanks so much. Now, here's the way we've got it planned,
Okay.
right? Or our organizers have planned it.
Okay.
We're going to have questions, maybe one or two after each speaker.
Okay.
And then we're going to have a panel discussion with all three speakers up here at once, where we're going to be using questions from the audience. So if you look there, right next to you someplace, there was a card, and you can hold off on your question until the three speakers are done, or maybe you're thinking, wow, Rob, I really want to ask you the question. The point is you can write your question there, and at the end of the program, when we're having our panel discussion, we'll do a little shuffling of the questions so that it's fair, and we may not get to everybody's question, but at least we'll get to a lot of them. And so I've got one for you, Rob. Okay, see, this is what the media isn't doing a very good job of. So let's see what you think about this. How is it that we could have so many worries about drought, and at the same time we're increasing our frequency of 100-year floods? And I think you kind of answered that, but that's a question that you often may not get, right?
I suppose, the answer is it's hard to think about variability. You look at, there's amazing data out there, which in some sense is surprising, but not surprising, but on the other hand is totally surprising. If you ask people how concerned they are about climate change, it will go up or down depending on whether it's a hot or cold day or whether you put them in a hot or cold room. The human tendency to project your current situation into the future is just very, very deeply ingrained. And so, from a physical point of view, there's no contradiction between being in the midst of a drought and having the precipitation we do get come in huge, intense bursts, which create floods. And so it's entirely consistent from a physical point of view to have, on average, much less precipitation, but have, intense storms. I mean, you all saw these pictures of Phoenix, which was underwater for part of the summer because they got these intense storms, even though they're in the midst of a drought as well. So, from a physical point of view, there's no contradiction between those, but it sits uneasily against the way that humans, the mental models that humans have of their world. So it would be nice if there were mechanisms, perhaps through great science classes, to help people match their mental models a little bit better to the way that the world sometimes works.
Yeah, thank you for that.
Sure.
Yeah, so, I often wish that the world would work the way I thought it should work, and it never happens. So we appreciate that.
I know the feeling, yeah.
So more questions to Rob when we do our panel
Yeah, great,
discussion.
okay.
All right, thank you, Rob, again. Okay, how are we doing? For our organizers, are you okay? So yeah, I'm doing great too, so I'm glad to hear that. Our next presenter, just moving right along with the most famous people in the world when we're talking about climate and water, our next presenter is Deborah C. Mann. Deborah is the Assistant General Manager and Chief Operating Officer for the Metropolitan Water District, what we sometimes call Metropolitan MWD. She is responsible for managing, I threw that in, by the way, I just thought it would be fun. She is responsible for managing the operational business functions of the district, which includes system operations, engineering, planning, and resources management. In this position, one of her primary duties is to implement the Chief Executive Officer's business plan and initiatives, as well as to oversee the application and operational practice of the board's policies and directives. She brings to her position 20 years of experience at Metropolitan in various aspects of business and water management. During this tenure, she was responsible for securing water supplies through agreements and partnerships with other water and agricultural interests in San Joaquin Valley and Southern California, and demonstrated Metropolitan's water supply reliability in compliance with current laws. She was also responsible for major initiatives adopted by Metropolitan's board, such as the Integrated Resources Plan, new rate structure, and facility plans, and environmental review for the district's major expansion of its distribution system and water filtration plants. But you don't get to hear from her right now because we have an extra special announcement. Judy Abdo is coming up here, former mayor of Santa Monica, and she wants to acknowledge that we have other really famous people in the audience, and you may be sitting next to one of them.
So who's an important person in this room? Everybody stand up. Okay? And some of you have elected some people that I want to just introduce very briefly. They can just stay where they are and wave. I can't really see where you are, but Ted Winterer is here. He is on the City Council of Santa Monica. Gleam Davis is here. She is on the City Council, Santa Monica. And Terry O'Day is the Mayor Pro Tem of Santa Monica. Yay, Terry. And I saw a school board member, Lori Lieberman, president of our school board. Are there other electeds that were able to sneak in without my eagle eyes seeing them? Looks like not. But if they sneak in, I will try and see them and let you know later.
Well, thank you, Judy. Judy is an example of so many of the citizens in Santa Monica who have stepped up in leadership roles and donated so much of their valuable personal time to make our community a better place. And wow, I think we need a round of applause for Judy as well, don't you? Yeah. Yes. All right, everyone, where's Deborah? Deborah Mann, come on up here from the Metropolitan Water District.
Great.
Deborah, you're in
Great,
charge.
now I can see.
Yeah,
Great.
take over.
Thanks. Great. Well, thank you very much for having me here. This is really a pleasure to talk to an audience that is really interested in water and cares about it, and probably would like to take some actions on trying to make sure we have reliable water supplies. So I have the great task of taking what Bill and Rob just talked about and translating it into the practical challenges of providing water service. And just as I interpret their assessments of climate change, I'm kind of looking at the National Oceanic and Atmospheric recent forecast, and that was there's a 67% chance of an El Nino, but it could be wet or dry. So the statistics that I have to work with in trying to figure out what's going to happen is that there's a third of a chance it's going to be really dry, a third of a chance it's going to be really wet, and a third of a chance it'll be normal. So thank you, Bill and Rob, for those statistics. What I wanted to emphasize is that providing water is such a vital utility service. Like electricity, natural gas, and transportation, these functions, including water, are so important and vital to the livelihood of our communities, the stability of our economy, and the quality of our environment. But there are some major differences on water from all these other utilities. Water is one resource that one cannot be generated. I can't manufacture new resources. I don't think anyone's figured that out. And it's really dictated by Mother Nature, as Rob and Bill have talked about. Hydrology and geology determine how much water there's going to be and where it will be. But there is also another significant difference, and that water is a public resource. It is a resource where no one can survive without it. No plant, no animal, no human can do without it, as it is so critical to just basic survival and sustenance. No other utility has that public resource importance. And so as I look at translating what climate change means to water supplies, it is one where as the drought continues, the climate change and the effects of drought will be continuously studied and intensely looked at by the scientific world and the researchers. But what is now before us is what to do with that in terms of translating it into what it means for our future supplies. And this is one in which, in this room today, we can either not sit back and look and see what Mother Nature is going to do, or we can take the actions today that will affect the reliability of our water supplies for the future. And so this is what I'm going to focus on from a regional perspective for Southern California. I want to just start off by talking about where we get our water, what this drought means to our water supplies, and how we have to manage through the drought. So where does Southern California get its water? I'm not sure if how many of you all are very familiar with this. Can I ask that question? Wow, that's pretty good. Okay, Bill and Rob, I expect you to know this. But I'm going to speak from just one perspective, metropolitan, which metropolitan is looking at Southern California as a region. I know Dean is going to talk about it for the city of Santa Monica. But for metropolitan, we're a regional water wholesaler, and we serve water to a 5,200 square mile area, which encompasses parts of 6 counties, all the way from Ventura, Los Angeles, Orange, Riverside, San Bernardino, and San Diego. Water is a uniform, universal issue for up and down Southern California. We serve water to 26 public member agencies, including the city of Santa Monica, and we have a 37-member board, of which Judy is an instrumental board member that has really moved us ahead on integrating our resources and planning for the future and other droughts. There are about 18 or approaching 19 million residences in Southern California. This is half of the population of California. And you can see, I don't know if you can see it very well, but down there in the very bottom on the yellow, that's where the 6 counties counties are. And in that small area, we have half of the population of California. We have a regional economy of $1 trillion, which is half of California's gross domestic product. And Metropolitan provides about half of the water that's used to meet the demands within Southern California. What I am trying to say here is that for our area, shown in that yellow, there's a lot at stake, and water is very important. So let's start off about where we get our water. First, there are local supplies in Southern California. I think Rob kind of hit on this. And again, if you see our square area, I'm sorry, it's a little low on this slide, but down there is our Southern California service area. We rely heavily, and this is very important, is conservation. We rely on groundwater recovery and our groundwater supplies. We have recycled water that has been developed, and we have surface water supplies, such as Rob mentioned, from the LA Aqueduct. But all of these supplies are very critical to Southern California. They're located right in our service area. And particularly, I want to note that conservation and our recycled water are two areas that are pretty much drought resistant. And so these two tools, or resources are very important to us, especially in a year like this. So all of these local supplies will meet about half of the demands in Southern California. The other half comes from Metropolitan's imported water supply system. And it starts off where Rob had talked about the fact that we have the Upper Colorado River Basin, which serves water through a series of reservoirs that capture the Colorado River flows. And then it goes further down, and then you can see where in this area here, we have an aqueduct system that takes that water to Southern California. What I want to mention is that we didn't just have this system just for Southern California. This is truly a partnership with 6 other states of Arizona, Nevada, Colorado, Wyoming, New Mexico, and Utah, and it also flows to Mexico. This is a system that many states rely on. We also get some water, and you can see in the shaded area the Northern Sierras, and what I'd like you to do is remember that. It's a major watershed area. It flows water into Lake Oroville, and it also then takes it through the Sacramento River and Feather River system and into the San Francisco-Sacramento Bay Delta area. And then we have an aqueduct system which takes the water all the way south to Southern California. And again, I just want to make sure everyone knows we didn't just build the system for Southern California. There are several other public agencies, about 26 other public agencies in Central and Southern California, and in the Delta they get water from this system. Many people rely on it, both agriculture, urban, and environmental interests. All of this water represents the other half of our supplies for Southern California. So, does that sound good? So far? Good. What I wanted to mention is that we have a very diverse supplies, and I want you to keep that in mind. And diversity is good, like not putting all of your eggs in one basket. While Rob and Bill are talking about how dry it's in one hydrologic region, it may be wetter in the other. And that gives us huge flexibility. And each of these supplies that we talked about has a different water quality. And water quality, because we ingest it, water because it's incredibly important to the health of our groundwater basins as replenishment, water quality that's needed for recycling and making it possible is very important. And so as we go through this, I wanted to talk about what this drought means to Southern California. I think you might all know this, but we have a watershed. And this kind of represents a watershed. And it's like the Northern Sierras where you have mountain ridges. And what happens is a watershed is a land area which captures and it feeds water either underground or through the surface drainage. And it takes that water and diverts it all into a water body, such as a groundwater basin, streams, reservoirs, lakes. These are where, when you see a water body, it's getting that water from a watershed. And typically, a watershed is pretty much defined geologically when you have mountain ranges that forms a bowl. So as a simple example, think of the fact that when rain and snow fall in this watershed, it's like an umbrella that's open and you turn it upside down. And when it rains, all of that water that hits the surface of that umbrella bowl flows to the middle, like a body of water. Same thing with snow. As it snows and it begins to melt, when it gets hotter during the spring, all of that water goes to the middle of that umbrella. So that's like a watershed here. You see, there's kind of like a bowl here. And that bowl is so important to us, and that the climate, in terms of how much rain, how much snow, determines how much runoff we're going to get, and goes into our water bodies, be it a reservoir or a lake, and that's captured water. That's our water supplies. So watersheds are very, very important, but that's a very simplified model because it's not all where anything that falls in this watershed is for our use. It's absorbed by the plants. We have to share it in terms of, in evaporation, and also we consume it along the way. So, how do you manage the imbalances? I think Rob talked about it when you pointed to that mountain range in the very north, a major, major watershed. It provides, in the north, about 2/3 of the supplies that are available to the state of California because of those mountain ranges that we had pointed to in the top. But as Rob had talked about, most of the population, 2/3 of it is in Central and Southern California. So your major supplies are mostly in the north, and most of the population and the use of water is in Central and Southern California. And so we have to balance that. And not only feast and famine according to hydrology. So as a result, what we have to do was make sure that, as we have pointed out before, you recall talking about Colorado and State Project providing about half of the supplies to Southern California. It required really investing in the past, as Rob talked about, an aqueduct system from the Colorado of about 242 miles, and also the State Project, which is an aqueduct system of 400 miles to get to Southern California. But huge diversity. Supplies are not in one place, very diverse supplies. So, as we listen to Rob and Bill talk about climate change, this is what's apparent to us. And if you look at this, you can see the California. Can you see the map of the outline of California? And here's the Colorado River watershed that we were talking about. What I wanted to point out, everything you see in yellow is considered already abnormally dry. When you look at the more the peach orange colors, they're now severe extreme droughts. So this orange stuff is extremely dry, and when it's this brownish orange, it is exceptional. Never been seen before in the record of our recorded history for the hydrology. And you can see that for California, over 60% of California is in that exceptional drought. All the population in California has been affected by that orange, which is a drought. It is unheard of where it's dry consistently throughout the state of California. So, Southern California, I wanted to mention, this is what we see. From a statewide temperature, we're already about almost 5 degrees hotter than the average for the first 6 months of this year. That's pretty record-breaking. And for Southern California, we're about almost 6 degrees hotter than average. And this is something that we haven't seen before in recent history. Southern California has been extremely dry in the last 12 months, but that temperature has been something that we haven't seen before in record. And this holds true for not just Los Angeles and here in Santa Monica, but also in all the other counties within our service area. What I wanted to mention is, here's my kind of academic graph, and I'm just going to say on the vertical axis you'll see the inches of precipitation, and then you'll see the kind of probability. And so this is like the average, this yellow line. Anything above it is wet, anything below it is dry, and this is like the 6th driest year in 137 years of recorded history. Pretty dry. And this is what it looks like. Do you remember the Northern Sierra Mountain Ridge, which I said was really important? It's a major watershed for our water supplies. That's what it looked like in January of 2013, and you can see the snow along that mountain ridge. This is what it looks like in January of this year. Pretty dry, not much snow. And as a result of that, this is what we have to deal with in terms of supplies. Lake Oroville, a major water body that captured those water supplies for the Northern Sierras. This is what it looked like in January of last year. This is what it looks like this year. This again is the inlet to that major body of Lake Oroville water. And this is the Enterprise Bridge. This is what it looked like last year. This is what it looks like this year. So we are, I think we agree, we're in a major drought. And so as a result, Governor Brown declared an emergency drought, calling for an immediate 20% reduction in water use. Metropolitan again called for a regional supply alert, asking for extraordinary conservation measures to be taken by all of our public agencies. And I think the city of Santa Monica, I have to credit, it was one of the first to just move ahead with this. State Water Resources Control Board adopted our emergency water conservation regulations and asked for mandatory outdoor watering restrictions, which is something that is a major use of water. So, in terms of washing down your driveways with water, in terms of washing your car with water, in terms of letting your irrigation system overflow and providing water running down the curb, and in terms of fountains that use water, all of this is being prohibited and goes towards the real need for water conservation and efficiencies. So how are we managing through this drought in addition to those measures? What we've done is I can't emphasize enough that the investments in conservation and local resources are huge for us. We've also invested in storage so that when it's wet, we capture that water, and when it's dry, we can pull from that storage and utilize it to meet demands. We have partnered with other agencies to make sure we can manage both agricultural and metropolitan water uses to the benefit of each of us as an additional supply. And the operational flexibilities in our system have been very critical. Infrastructure is so critical. It gives us the flexibility to take water from various sources to different areas of consumption. And we have met demands, the consumptive demands in this year. So what I really want to show, and it's really too bad because I really like these pictures at the bottom, but I wanted to tell you that regionally we have all of you have invested in conservation. So much though it saved water, which is almost like twice, it exceeds a full Colorado River aqueduct, which is a huge amount of water that has been saved. And we've invested in water efficient toilets, which I hope you can see. And also, we have efficient clothes washers. We've also invested in outdoor landscaping in terms of California friendly, looking pretty good in that third slide. And also irrigation in terms of control systems that tells you how much water should be applied. It tells you soil moisture sensors. And it also has rotating nozzles. And what we've also looked at is turf removal. All of these are important. They're critical in saving water. What I also wanted to show you is local resources are absolutely important as well in terms of taking what we have and making it last, making it even more beneficial. So we've taken recycled water, we've recovered our groundwater basins, and we need to do more of this because managing what we have is going to be important. So I wanted to show you since 1980 the efforts that the City of Santa Monica as well as Metropolitan and our public agencies have done in terms of recycled water and groundwater recovery. You can see there has been an exponential increase in that capability, and this is what's making a big difference in how we're dealing with this drought. So you can see that it's a huge increase, and Metropolitan provides financial incentives to the City of Santa Monica for conservation and for local resources development, as well as our other public agencies. This is our bank account. we have developed storage, so it's healthy for us to store water in groundwater basins when it's wet. What a great way to save resources. So before it's really wet in those flood conditions that Rob tells us we're going to have soon, what we would do is capture that water and try to put it in a reservoir in our groundwater basins and save it. It's like a bank account. And so when you can see we've done that in 2006 on the left to 2007, it got dry, so we reduced it, drawing from our bank account. And you can see, as Rob talked about, yes, it got wetter, and in fact in 2011 it was a gangbusters wet year. What we did is captured it, we stored it in our groundwater basins, healthy for our groundwater basins, we stored it in our reservoirs, available, and so we built up our bank account, and now we're withdrawing on it. And so that's the other way in which we're trying to drought-proof water supplies that are more hydrologically impacted. So these investments have worked, but what if the drought continues? And this is our game plan. So I know Judy knows this. You probably could give Gim this speech. But our whole game plan is to change and to emphasize conservation and local resources to make more available within our service area. So you can see back in 1990, conservation and our local groundwater and recycled water, and potentially the LA Aqueduct, although nowadays I can't tell what there is, but is about 41% of the demands back in 1990. Our goal is by 2035 to have 2/3 of our demands met through conservation, water use efficiency, recycled water, making better our groundwater deliveries, and potentially stormwater. And I know that Dean's probably going to talk about our joint study on stormwater that's coming up and capturing that available supplies. That is our game plan. So much so that up until now, when you add up what we've done in conservation, water, recycling, and groundwater, we saved about 1 billion gallons a day, and that's equivalent to the total demands of the city of Los Angeles, San Diego, and San Francisco. We plan to double this by 2035. I wanted to point out, if any of you are interested in conservation and the rebates that are being available for landscaping, for indoor plumbing and water use efficiency measures, you can look at bewaterwise.com, and I know Dee Zink is in the audience. She heads up our external affairs, done a great job working with the City of Santa Monica and others in terms of getting the word out about how we can be more efficient, more responsible. And you can see that from October to July, it has skyrocketed. So please look at bewaterwise.com and please get involved. The per capita water use, I just wanted to go through very quickly, is making a big difference. It shows how effective Southern California has been. In 1985, our per capita water use was about 205 gallons per capita per day. Our past 10-year average has now taken it down to 180 gallons per capita per day. And for the 6-county region, our average is now hovering around 150 gallons per capita per day. This is a 24% reduction in our per capita water use since the late 1980s. And it's pretty phenomenal, and I don't think any other part of the state can point to that. The other thing I wanted to mention, because I know that people say, what happens if there's growth? The green is the service area population, which grew by 5 million. So despite the population growing over the next by 5 million since 1985, we have managed through water use efficiencies and conservation and through local resources development to keep the retail demands flat. That's pretty phenomenal. But there's still to be more to be done, and this is where I turn to you, and I hope you're getting more interested in this. Outdoor conservation is important. We've done a great job with indoor conservation, but outdoor conservation constitutes about 40 to 70% of your residential use. And therefore, we need to move forward with drought-tolerant landscaping. We have a turf removal program because it's important for us to make sure that we have California-friendly, not water highly intense using turf. And there's been a great deal of interest in that. We need to have stable imported supplies. So while we're not planning to increase our imported water supply deliveries, we want it to be reliable. We want to make sure it is reliable because of not just providing a basic amount of water to meet consumptive needs, but for water quality purposes. And so you have the Colorado, and we're working with the other states on making sure that we have a good effort, because it's not just what Metropolitan and California does, it involves all the other states that use Colorado River water. We all need to be responsible. State Water Project, we're looking at the Bay Delta Conservation Plan. We're investing to make sure that we have a reliable delivery system that can bring us the water during wet years so we can use it during dry years. And it's also important for making sure we have high quality water to put in our groundwater basins and recycled water.
That was your 10-minute warning.
Okay, sorry.
You're over about 10.
I am? Oh, sorry, I couldn't see. Oh, great. I'm so sorry. So I'm going to just summarize, but please get involved. The actions we take today are important. There are things that we can do for Southern California and to make sure and ensure that we have a reliable future. Thank you.
No, that's great. Great presentation by Matt. And since we've got you up here and we asked one question of the other speaker, so we're running a little bit behind, so I thought I'd pick out a yes or no question. Okay. Ready? There's 2 yeses or nos. Is it true that the Metropolitan Water District is the largest water district in the world? And if that is true, then your water efficiency efforts could be a model for a world running out of water. What do you think about that?
Well, I want to say yes, we are the largest water wholesale district. And yes, I think all of you in this room deserve a lot of credit. I have to say the City of Santa Monica deserves a huge credit because what we do shows leadership. And so we have been one of those that has been pointed out by the governor and others of showing how water conservation can be achieved.
Oh, okay, thank you again, Deborah. So remember, we'll have audience questions coming in during the panel discussion, but running just a little bit behind, not too bad. In fact, our next speaker is Dean Kubani. Now, talk about a star for the city of Santa Monica and a wonderful neighbor. Dean Kubani is the director of the city of Santa Monica's Office on Sustainability and the Environment. He oversees all of the city's efforts related to, you know what, I just need to stop for a second. Dean, just if you don't mind. You know, I was thinking that on Tuesday, you know, Tuesday's the big weather change. So if we could all just agree that on Tuesday we're going to go outside and we're going to take a really deep breath and we're going to blow toward the east, okay? Just agree with me on this. And by doing that, we're going to blow that high pressure system out of here. If we can just all do it at once, right? And bring the low pressure in, and maybe we can get some rain. Now, what was I doing? Oh yeah, Dean, okay. Anyway, Dean Kubani, he oversees all of the cities. Are we going to do that, right? So when it starts raining on Thursday, we can say, we did it. It was this forum. He oversees all of the city's efforts related to water and energy efficiency, urban runoff, green building, hazardous materials, and sustainability. Since 1994, Dean has directed the ongoing development, implementation, and evaluation of the Santa Monica Sustainable City Program. He lectures on sustainability at universities throughout the country and has presented information about Santa Monica's programs at state, national, and international conferences. Dean sits on the advisory boards of the International Sustainability Indicators Network and the University of Southern California Center for Sustainable Cities. Please welcome our friend, Dean Kubani.
Thank you, Bill. Bill, that was the best introduction I've had all day. Thank you. You forgot my Nobel Prize, though. But, so if we do need to make up time, Or if you just don't want to pay attention to my presentation, I've put the final summary slide right here at the beginning. So what I'm trying to get across is every drop counts, use less, diversify, manage your water wisely. Now you can all go home. What I'm going to talk about is Santa Monica's water, where our water comes from, how we use it, and most importantly, how we can all, working together, sustainably manage it. First, the value of our water. If you go to the local mini mart or your gas station and buy a 16-ounce bottle of water, it'll cost you about $2. That same $2, if you used it for tap water, you could refill that 16-ounce bottle 2,400 times. So that's roughly about 300 gallons for your $2, which is pretty amazing because, as we all know, water is incredibly precious, and it's getting more precious, but we are able to deliver it right to your home, to your faucet, for basically a pittance. I think it's the best deal in the world. You used to have to, my grandfather used to have to walk out to the well and pump it and carry the buckets back in. We bring it right to you. So this is probably one of the best deals of anything that you ever get or use. Santa Monica provides almost 12 million gallons of drinking water to almost 18,000 customers every day of the year. And like I said, we make your life easier. You don't have to go out to the well or down to the river with buckets. Santa Monica serves over 90,000 residents a day, 7,000 businesses, and up to 200,000 visitors with water every day. And this is a breakdown of the various customers that we have. About a quarter of our customers, or about a quarter of the water is used by our single-family customers, a little more than a quarter by commercial customers, and about 43% by multifamily. The one thing that you should know about this is 70% of the people who live in Santa Monica live in multifamily units, and they only use 43% of the total water. 30% of people live in single-family residences, and they use a quarter of the water. So actually, the folks that live in multifamily residences are much more efficient. They use about half the water of single-family residents. So Santa Monica started selling water back in the 1920s. We became a founding member of Metropolitan Water District in 1927. We have 10 groundwater wells, another one's going in. Several of those wells are in the city of Los Angeles on land that the city of Santa Monica owns. We have 2 imported water connections. Those are our 2 metropolitan connections to Metropolitan Water District's water. We have 2 treatment plants. One is the Arcadia treatment plant out by Wilshire and Bundy, and the other one is the Charnock plant, which is out in West Los Angeles. We have over 250 miles of water main, and we use reverse osmosis to treat that water so that you're getting the highest quality pure water out of your tap. This is a picture of Santa Monica's first water treatment plant. I believe this is the Arcadia plant back in the 1930s. And here's a picture of that plant today. This shows one of Santa Monica's reservoirs, and up in the upper left is the reverse osmosis treatment system that went in, came online in 2010. This chart shows how Santa Monica, how much water comes from local sources and from imported water. We're getting about 60% of our groundwater is local now, and about 40% is imported from the Colorado River and other parts of California. A little bit less than 1% is recycled. That comes from our SMRF, the Santa Monica Urban Runoff Recycling Facility, which is down by the Santa Monica Pier and captures runoff from the streets and treats that for reuse. What's interesting about this is back in the early 90s, we were up to about 70% local groundwater and 30% imported water. And then in 1995, we discovered a chemical in our groundwater called MTBE. That is a component of, or was a component of gasoline that leaked into the groundwater from underground tanks and pipelines and contaminated almost all of our wells. So at that time, we dropped down to getting only about 10% of our water locally from our wells and having to import 90%. By 2010, when we put in that new treatment plant that I showed on the picture, we were able to start reversing this trend, and so now we're moving back towards the 70-30. One other date to note is in 2011, Santa Monica City Council set a goal of becoming water self-sufficient by 2020, which means we want to get to 100% local water and stop buying water from Met. Sorry, Deborah. But actually the purpose is not because of Met, it's because that's helping stretch the resources for everybody in the system. This map shows the groundwater basins in Southern California, and up in the upper left is where Santa Monica draws all of its water. It's the Santa Monica Basin. This is an unadjudicated basin, which means pretty much there are no real rules. If you own land and have the wherewithal to put in a well, you can draw water out of the basin. One thing that is important to note is that this groundwater, this local supply, is about 60% cheaper to produce than imported water. So the water that Santa Monica buys from Metropolitan Water District that comes from a long way away costs over $900 an acre foot. An acre foot is basically a football field 1 foot deep in water. It's 300,000 some odd gallons. The same amount of water Santa Monica produces is around $400 an acre foot, so it's much cheaper to produce local water. And as we've heard, it's better for us to be producing local water. All of these straws in the sand represent our wells. We're basically sucking water out of the aquifer underneath us. In 2011, the city did a groundwater study and estimated that the Santa Monica Basin has about 300,000 acre feet of water in storage in that basin. The city, we use overall about 13,000 acre feet, but actually we're drawing about 9,000 acre feet a year. And this basin is recharged by rain. So we're right now probably using our water at very much below the sustainable capacity or sustainable rate. There are not many people taking water out of this groundwater basin right now, and when we get rainy years, it fills back up. And the city's been managing this basin in a sustainable way for over 100 years, but this is something in the age of drought, where drought is becoming more frequent and is kind of the new normal. We're going to have to be much more cautious and conscious of the water levels and the level in this basin, because this is what supplies our water. So I mentioned water self-sufficiency by 2020, this goal. Really the way we're going to do this is, and Deborah mentioned this as well, sustainably manage our water by drawing some additional supply from local groundwater sources, so putting in some new wells to pull out a bit more groundwater, and then increasing significantly our water conservation efforts so that we can ultimately by 2020 stop importing water from other parts of the country. And as everyone's talked about today, we've had several years of warm weather and little rain, and that's impacted both our local water supplies, and you've already seen this map a couple times of the statewide and even further afield water supplies. So what's happened recently in Santa Monica, in August of this year, our city council declared a stage 2 water shortage. And what they asked city staff to do was to come back with a water shortage response plan that basically mandates conservation and will require all of our water customers to cut their water use essentially 20% from a 2013 baseline. We plan to go back to City Council when they adopt this plan, and we're still working out some of the final details of it, but we'll take it back to Council January 13th, and if and when Council adopts that plan, water allowances will go into place for all residents and businesses and landscape water customers starting that month, and drought surcharges will likely start sometime in the spring, where if you exceed your allowance, you'll be paying a surcharge or a penalty on that extra water that you're using. So this graph just basically shows what our 20% reduction goal looks like. Over here on the left is we're using just under 12 million gallons per day. We want to get down to about 9.6 million gallons per day, saving 2.2 million gallons every day. And so now we're going to focus on how we're going to do that. This chart shows how all of us use water at home. And this is obviously averaged, but inside the home, the highest water users are your toilet and your clothes washer, followed by showers and faucets, and surprisingly, leaks. And I don't know how many of you have checked for leaks recently, but that's something that we're going to advise that you do. The average home in Santa Monica, on the left is a single-family home, on the right is multifamily. The average single-family home uses more than 22,000 gallons of water every 2 months. That's a 2-month billing period. That works out to about 375 gallons per day. The average multifamily unit uses 6,700 gallons per 2-month billing period, or about 112 gallons per day. And the difference in that, most of it is because single-family homes, about 50% of their water use is used outside of the home for irrigation of landscapes. Very little landscape irrigation happens at multifamily units. So what does a 20% reduction look like? For the single-family home, or the average single-family home, that's saving about 75 gallons of water a day. For multifamily, per unit, saving about 22 gallons per day. One thing that when we're talking to people about reducing water, a lot of people in Santa Monica are very conscious of energy use, water use, the environment, and they've been doing just about everything they can to save for a long time. So a lot of people come up and say, how am I going to cut 20%? I'm already very efficient. We're proposing that council adopt a residential water use threshold. It would be set at 22 HCF. HCF is it means 100 cubic feet. It's about 700 odd gallons, and that's the billing unit that's on your bill. That works out to about 16,500 gallons per 2-month billing cycle. If you use less than that on your water bill, you're not going to be asked to cut your water use an additional 20%. Likewise, if you live in a multifamily unit and you use less than 11 HCF per 2-month billing cycle, you won't be asked to cut. Already 42% of our single-family residences and 80% of multifamily residents are below those thresholds. So we're doing very well, and a lot of people are not going to be impacted or asked to reduce more, although we certainly encourage you to do as much as you can. So how are we going to get there? These are our top 5 recommendations. Take shorter showers. Check for and repair leaks in toilets, faucets, showers, and irrigation systems. You probably picked up some of those leak check tabs out in the lobby. If you didn't, we have a lot of those to check your toilets. Replace your toilets with ultra-high efficiency toilets. Even if you replace your toilet 7 or 8 years ago. You can get better toilets now. Replace your top-loading, inefficient washing machines with Energy Star front-loading machines. Old washing machines can use up to 40 gallons of water per load. The new Energy Star front loaders use 3 to 4 gallons. So this is a great way to save water. And then replace your lawn with water-smart plants, mulch, drip irrigation. These last 3 things, the city and MWD give rebates for these things, and I'll talk about them very quickly. So taking a 5-minute shower, you can save about 1,400 gallons on your bill. Fix a leak, you can save over 2,000 gallons. Swap out your toilet, save 850 gallons per billing cycle. Wash wisely, replace your washing machine with a front loader, save almost 2,000 gallons per bill. Take out your lawn and replace it with efficient water-wise plants. Get a $3,000 rebate, save over 2,500 gallons per bill. Other things you can do, diversify. We give out a very generous rebate for rain barrels and cisterns. A rain barrel costs about $150. Santa Monica will give you $200 in rebate if you buy a rain barrel. And so you can use some of that extra money for installation of it. And then this is extra water if and when it does rain, Bill. If we all blow east on Tuesday, right? Will offset the amount of water that you need. You can scale back your irrigation timer and reduce the amount of water you're putting on landscape because you can use rainwater. So this picture of a faucet with money coming out of it goes back to that very first picture of how much is our water worth. Every time you leave the faucet running, you're wasting money. We're all water managers in this drought, and like I said, this is a new normal, so we need to think about wasting money and wasting water. You're going to help not only the Santa Monica community, but also statewide and region-wide by saving water. And you're also staying within your water allowance and avoiding any water charges or drought surcharges that you might otherwise pay. I can't see this on here. There is, I guess the image that I had on here is not showing up, but what's coming is My Water Report. We sent out some surveys very recently, which is a tool for single-family customers that you can sign up for that will tell you very clearly how much water you're using, what your allowance is, how much water your neighbors are using, and it kind of ranks you to show you if you're a water waster, a water saver, or somewhere right in the middle. And it will have links to rebates and other ideas that I've talked about on ways that you can save water. So if you haven't seen it yet, you'll be seeing something in your bill if you're a Santa Monica water customer right now. We'll send out bi-monthly reports. You can set up an online profile. You can get these things via email. So this is just a way that one of the things that we're doing to help you save water. Oh, there's the table. That is what it'll look like. And I'll end here with Santa Monica is a customer of its own water, so we're required, the city of Santa Monica is required to cut its water use by 20%. So these are some of the things that the city is doing. Most of our buildings now, including this building we're in now and the new Pico Library, have cisterns. So when it does rain, we're capturing that water and reusing it for irrigation and also for toilet and urinal flushing. I mentioned Smurf already. We're looking at the city's water treatment plant to increase the efficiency of the reverse osmosis system. We're systematically going through all of our facilities and looking at replacing and updating toilets and urinals with high efficiency fixtures, and we're looking at all the city landscapes and replacing inefficient irrigation, making sure that we don't have any leaks. And I'm going to end right there, and remember, I started with this, every drop counts, and we're all in this together, and I'm looking forward to taking your questions after Bill gets up and asks me one. Thanks.
All right, thank you, Dean. Well, we're running still a little bit behind, but you did a great job, and I want to thank you for all the work you've been doing with the city. And everybody here who's done their part. We have so many volunteers, except for the $1 million I'm getting paid to be here today. They're all volunteers. All the speakers are volunteers. All the people who organize this are volunteers. So could we just give everybody a round of applause? And so the next step to this is that we're going to have a panel discussion. We're going to have all three speakers up here, and we've got a ton of questions that we're going to sort through. And I guess that'll take us about a minute or two to set up. But before we do that, Judy's going to say something. Judy, what do you want to say?
Earlier, I introduced Ted Winter, Terry O'Day, and Gleam Davis, and now we have been joined by Sue Himmelrich, the newly elected City Council member from Santa Monica.
Now I have the first question, and it must be for Dean because he didn't get a question yet. All right. So here it goes. Ready, Dean?
I'm ready.
All right. True or false? No, it's not. I made that up. How will the city allow landlords to share water costs with their tenants?
That depends. If you're a landlord in a building that's not rent controlled, you may have a contract with each of your tenants that may or may not include water costs, so that will be between the landlord and the tenant. Most of the multifamily units in Santa Monica are rent controlled. So, yes. And on December 12th or 13th, I believe, is that the right? 11th, December 11th, the Rent Control Board is actually going to be discussing this very topic. Back in 1991, when there was a similar severe drought, the Rent Control Board allowed landlords to pass through a percentage of the additional costs or drought surcharges to their tenants. Not the whole thing, but a portion of it. So they're going to hear the same thing. The Rent Control Board will deliberate that. If you're concerned about it, I recommend that you go listen to that discussion in December. And so it is possible, just like in the past, that some of that will be allowable to be passed through to the tenants. And I did want to point back to one of the things that I showed on my slide is that already 80% of the units in Santa Monica are below the threshold that's been set already. So most of the multifamily properties are not going to be incurring any drought surcharges right now, based on current use.
Yay. Wow. Well, I think Dean gets the award for the most thorough answer to the first question. That was beautiful. So let's run through them, everyone. How many gallons, now we'll see who can answer this one. I feel like I'm in Jeopardy. I know. Anyway, how many gallons of fuel does it take to deliver 1 gallon of water to Santa Monica, to a Santa Monica user? I don't know. Anyone want to guess at that, or? Well, what we can tell you, since they're not talking, is that it turns out, a lot of you may not know this, if you've ever carried a bucket of water, how heavy it is, it turns out that the pumping of water is one of the greatest costs for all water districts in California. Did I get that right, Deborah? Yeah. Oh, okay.
Particularly from the northern.
Right. Yeah, particularly when we're moving it from the Colorado River from northern to southern California.
Yeah, and there's the number that, what, 20% of California electricity is for the pumping and treating of water. Is that the right number?
Well, actually, can I elaborate?
Yeah.
Yeah, you're talking about there was a very good study done by the California Energy Commission. And when you look at the total energy consumed in California, water and wastewater in total, and stormwater, for all of these water-related functions represented 20%. But out of that 20%, when you look at it, about 15% of the water used were for homeowners or end users, by the fact that water is used for, the HVAC, water is used for cooling towers for industries. So about 15 of the 20% of the 19% was actually used by the end user. And for pumping water, for example, in the State Water Project, it was about less than 4% of the California energy consumption. And for Metropolitan's part in our distribution system, it's less than 1%.
Wow. We got the right people on the right panel, that's for sure.
I can also say that we recognize that energy and water are linked. They're absolutely linked. They're so important that we deal with them together. So that's why when we move water, we're really maximizing hydropower. And we're actually looking at, in fact, Metropolitan itself in our distribution system has over 16 hydropower plants. And we're putting in solar energy at our treatment plants. So we recognize that when you save water and you save energy, it really conserves on both sides, and it also saves money. So that's where we're headed.
Beautiful. All right, next question. Does Santa Monica's water well supply suffer from the possibility of saltwater intrusion?
Gil could probably answer that better than me, but I'm not going to put him on the spot. Gil Borbeau in the back is the city's water manager. If we had water wells near the coast, I believe it's something like west of Lincoln Boulevard, if you pump that water, it would be brackish and it could be drawing in salt water. But all of Santa Monica's water wells are much further east than that. And the pumping of that water is not drawing significant amounts of salt water that's impacting our aquifers. Is that correct, Gil? All right.
Hi, Gil. I see Gil all the time.
That's great. Okay, well, this is a similar question about what percent of our energy is used to pump the water. But then it states, and maybe Rob, you'll be interested in this question, how does that energy use go towards global warming?
Well, it depends what we're burning, if that's what we're burning, to produce the... That's right. Oh, I'm sorry. Well, it depends on the source of the energy. So to the extent that we use renewable sources, then very little. The extent that we're burning natural gas, definitely more so. So, I mean, California's energy generation, electricity generation in particular, is far below the national average in terms of its carbon content. But I don't know exactly which sources we're using for the water.
Complex questions. And here's another complex question. How serious do governments really take the Kyoto Protocol, and how will any agreement help stop climate change? And I think Rob knows why that's a complex question.
Yeah. Well, let's see. So where to start that? The Kyoto Protocol is an agreement that's almost 20 years old now, which is part of the umbrella international agreement called the Framework Convention on Climate Change, which is the sort of the international infrastructure for dealing with climate change. And part of that is this IPCC reports, these scientific reports that come out every 5 years. Europe is a party to the Kyoto Protocol, the United States is not, but more apropos is that the world is gearing up for the Paris negotiations. It's called the Conference of Parties, which is when all the nations of the world get together to negotiate about climate change. So the next really big date is in Paris in 2015, so a year and a month from now, which is the target for coming up with the successor to the Kyoto Protocol, because the Kyoto Protocol has essentially run its course and run out now. And so this is the big milestone for agreement. and the recent U.S.-China agreement, which President Xi and President Obama announced last week, is really sort of the first big announcement in the lead-up to the Paris 2015 agreements. And the things to watch for there is we're trying to get. The idea is to get all the countries of the world to pledge different emission reduction programs, and not the Kyoto Protocol just applied to developed countries like the United States and Europe and Japan. This time, trying to bring in all the nations of the world, particularly what used to be called developed countries, but now are high-emitting countries like China and India. And so the part of the importance of the agreement last week was this is really the first time one of these large, fast-growing developing countries has committed to emission reduction. So that's actually a fairly big deal.
Good. Bill, can I just add to that? Because you said, how serious are governments taking Kyoto Protocol? Santa Monica is a government. I wanted to put a plug in for that. Rob, what was the target for Kyoto was by 2012 for the United States was like a 7% reduction in greenhouse gas emissions. So Santa Monica took the Kyoto Protocol seriously. By 2012, we reduced our emissions 14% below 1990 levels. We have a 15 by 15 climate action plan, 15% by 2015, which we'll get to. And then our council's adopted goals of an 80% reduction by 2050, and we're already looking beyond that. So Santa Monica and a lot of local governments are taking it very seriously and are actually doing the work that our state governments and federal governments should be doing.
But the California program is pretty impressive as well.
You're right.
So you may be referring to other states.
Okay.
Well, it's starting to sound like a panel discussion. Well, that's beautiful. And you reminded me, I'm looking at these questions. They go from global to local in scale. And it reminds me how each person does really make a difference, how we're all connected to this global network. And this is a perfect example. It's important to consider the effects of the military on global warming and resources. Please comment on the effects of foreign policy on the military influence on the depletion of resources, pollution, and climate change. Who wants to tackle that one?
Deborah, do you want to start?
On foreign policy, let's see, I have to give some thought to that one.
Okay.
Bill, I think that's what the Stephen Colbert video was supposed to be.
Pretty much.
You don't need that question answered.
Okay, that's a rich, multifaceted question. So, I mean, number one is that we spend a lot of money protecting. We, the U.S., spend a lot of money protecting, global oil supplies. So, which is a cost which is not always factored in to the, the price we pay for things like gasoline, and so, I mean, one contribution, one impact is that we may be, we again, U.S. and globally may be underpricing the real. Both the cost of producing gasoline as well as underpricing its, its more global impacts. So I think that's one answer to that question. Actually, the U.S. military has a number of programs to try to develop alternative fuels and is actually taking the decarbonization rather seriously, so trying to come up, be a technology leader for things like, low carbon aviation fuels and low carbon transport fuels and that sort of thing. So that's a benefit to some of our activities. So, there, as in many things, there are costs and benefits.
That was really good. Thank you. Yeah. So now we go local. In a city like Santa Monica, what has the greatest impact on the water deficit? Or the water demand, excuse me, it's called water demand.
What, can you say that again?
In a city like Santa Monica, I'm not sure what that's supposed to mean, but what has the greatest impact on our water demand?
I'm not sure I understand.
That's not a good question.
I couldn't say that, but thank you. No,
Well, you showed that.
I think they're
Yeah,
asking.
I did show a slide up there that shows how we use our water in our homes, and the biggest water users. Your toilet is the biggest water user in your house, followed closely by your washing machine if you have one of those. That's all inside your house. If you live in a single-family home, it's quite possible that the most water you use is outside. And a lot of people in this city over-irrigate their landscapes. They may not even set their irrigation timers. They may not know if they have leaks because they're set to go off hopefully in the early morning or at night. But that's one big area, if you live in a single-family home, where you can reduce is learn about your irrigation system and your controller. And we've got some staff over here in my office, Russell and Kim, who can help you. And we've got folks that will come out and help you figure out where you're using the most water and how you can save. How's that?
You forgot to say the amazing Russell and Kim.
The amazing.
Yeah, right on. Okay, if Santa Monica becomes water self-sufficient, but neighboring communities don't, how will the city work with communities which might need our water?
Meaning, once we become water self-sufficient, and are we going to be helping other communities stop using so much of this imported water too? Absolutely. Bill's introduction of me mentioned that I started in 1994 when the city adopted its Sustainable City Plan. One of the key guiding principles of that plan is that we're not going to become a sustainable island. We realize that we can't do everything to become sustainable here without helping other cities either right next door or across the country. So for the last 20 years, we've been working, and me and my staff and other people in the city have been working with other cities to, basically the things that we do here are examples or best practices of what other cities can do. And in fact, lots of cities are copying what we're doing here in Santa Monica, and we're definitely going to continue that with whatever we're doing. If we can achieve water self-sufficiency here, we're certainly going to help other cities, particularly our large neighbor to the east, Los Angeles, save water too.
Actually, can I add to that?
Of course.
I think that as a region, we recognize that it's not just what one city does. I think we have to consistently work together so that it's across the board in terms of water use efficiencies that we meet and in terms of the kind of actions that we take in not only how we manage and use our groundwater basins. So I think that's where there is a huge collaborative effort. I know amongst the public agencies of Metropolitan, there is a consistent recognition that we have to meet conservation goals across the board. We have to develop local resources and meet those goals across the board. And so I think that while we hope for mutual assistance, I think that working together and collaboratively, not just city by region, that we will have that across the board achievement of water use. And every acre foot of conservation and recycled water that we develop is very valuable. It's saved. But it means that that's an acre foot of water that can be put in our bank account so that if we do face really prolonged droughts like this, that bank account can serve everybody because of what everyone's done. And so we see how that works. So it's not just you're getting off of Metropolitan, it's the fact that we are saving the water and making it valuable and accessible in a prolonged drought like this one. And that's how we drought-proof this Southern California region. And I want to say this as well. From a metropolitan standpoint, it's not just what Southern California does, it's also what we do up and down the state. And I think that there's one great thing about a crisis, even though it's really uncomfortable and not very much fun, it really highlights the opportunity for everybody up and down the state, Northern, Central, and Southern California, to recognize the seriousness of this problem and to take action together. And I think that that's something that we're hoping to achieve, not just in Southern California, but for the entire state.
Well, it sounded almost like a wrap-up statement.
Wait,
but-
Bill, I have
yeah.
a question for you.
But it wasn't.
Actually, this has been burning in my mind as you were saying that you were riding your bicycle, thinking about, the celebrities' hairstyles and food. So, what celebrity were you thinking of that just had you totally?
I totally made the story up. On my way over here, I thought, what would be a great story? And I was thinking about the popular media and what people focus their attention on, the things that really don't matter. It's amazing that we've been strangled into thinking that way. It's pretty sad. Well, one more question, and there's so many. We've got a whole stack of them in here, and we're already out of time. We're 3 minutes over, but this is about recycling. And so, what will it take to build infrastructure to recycle our water throughout our Southern California region?
I love that question.
I thought you would.
Yes, recycled water is so important as a resource, and I know that we've been doing it locally by communities and locally by cities. I think that there is now recognition that you could really make this resource count by having it available on a regional basis. And so I think that's where there's collaboration. So we are pursuing projects that are not just from one agency, but multiple agencies. And infrastructure will be important. Infrastructure to treat and purify that water, infrastructure to take that water from the source and get it to each of our consumers is very important. And so I think that's something that all of us will collectively invest in. I know that we recently passed the Proposition 1, where the governor recognized how important this is, and under Proposition 1, which is a $7.545 billion revenue source, state funding available. A good chunk of it is for recycled water, and I think that's our opportunity to make sure that we can pool our resources from a local standpoint, a regional standpoint, and statewide funding, and really develop regional recycled water for Southern California. And so we look forward to that opportunity. We'll be moving in that very quickly.
Wow, beautiful. Well, thank you again. Well, everyone, before we call it a day, we have some closing remarks, and of course we want to hear from the folks that made all of this possible. So if I could get Zach Gadzik up here, and if you could talk about the Climate Action Santa Monica, and tell us what's going on with all of you.
Hello there. So you've seen me scurrying about trying to make the media work as best we can. And first off, I just want to thank you all so much for being here, for taking the time to really learn about this stuff and connect with each other, connect with your neighbors, connect with your community. So anyways, I have a little history that I just want to read because you may be confused. We used to be the California Climate Change Exchange, and now we're Climate Action Santa Monica. So let me just read this history a bit. So in 2012, a group of concerned Santa Monica residents convened to explore local solutions to the growing threat of climate change. California Climate Change Exchange was formed as a project of the Church and Ocean Park in Santa Monica. A program, thank you, a program of direct education of local residents and businesses became the centerpiece of the organization. And with a grant from the City of Santa Monica, thank you so much, the California Climate Change Exchange was able to mount a series of successful public forums. This is our third one that we've done. You can actually go onto our website, Climate Action Santa Monica. There's a reason why we shortened it, .org, in order to watch our first two forums, and this one will also be available online so you can learn lots of information about it. And so we realized originally we'd had this idea of connecting people online, but we went, there's a lot of stuff going on online. There's a lot of Facebook and Twitter and all that stuff, but there aren't that many opportunities as a community to sort of get together with your neighbors, with your friends, and talk about these issues and learn about these issues with these fabulous panelists. We're able to tell you so much about water, probably more than you ever wanted to know, about where your water comes from and what you can do to conserve it. And so we thought, these forums are really the focus, and here in Santa Monica, that's where we want to focus our efforts. We also have a number of working groups. We have a electrical grid working group, which is sort of helping to focus towards moving towards CCA, community aggregate electrical production with 100% renewables, sort of get the city onto that track, as well as a group that's helping the Santa Monica Malibu Unified School District sort of have a lot more integrated education about environmental sustainability. So that's kind of what we're doing right now. I want to thank everyone again for coming out here for learning, and that's all.
And we have a reception.
Oh, yes.
Yeah, so to wrap all of this up, everyone, we do have a reception for the next half hour or so. We welcome you to. And you know what I was thinking about? I was thinking about all of the combined energy, expertise, the knowledge, and the caring that has been in this room for several hours. And if you don't think that that makes a difference, you missed something, because there's a lot of positive out there. There are a lot of positive things happening. There's a lot of hope for the future. We hear all the negative, but I'm an optimist, and I think folks like you and folks like these are going to make such a positive difference that the future is so bright, I'm going to need shades, especially here in Santa Monica. So again, thank all of you for your volunteer work for coming today.